In an effort to improve the mission readiness of the U.S. Air Force's C-130 fleet, STOL Aviation International, in conjunction with Engineering and Professional Services Incorporated, under contract to the U.S. Air Force Research Laboratory, Wright-Patterson Air Force Base, Ohio, has completed the successful demonstration of specifically designed aerodynamic wingtip-mounted fuel tanks. These functional tanks have shown a substantial improvement in aircraft performance in nearly all aspects of flight. Building on experience from past programs, the STOL Aviation team modified the structural design of the wing tip tank that they had previously designed and flown on a C-130 during the persistent Herk 2 program of 2004. The structural design modifications focused mainly on field maintainability, with a specific concentration on compatibility with current support equipment and producibility enhancements. In addition to the structural changes, the equipment needed to make the tanks fully functional was added to the tip tank design. Fuel system modifications were also designed and integrated into the aircraft test bed to accommodate wing tip fuel tank functionality. STOL Aviation's C-130E testbed aircraft, which was used for the first phase of the STOL Herk program, was used for demonstration flights with the tip tanks. This aircraft was already instrumented for flight test data acquisition and required little modification to collect necessary data for the STOL Herk tip tank program. The aircraft was already outfitted with the Hamilton Sunstrand NP2000 propellers, extended chord rudder, and extended dorsal fin, also from the first phase of the STOL Herk program. Using this C-130 testbed, an instrumentation platform provided significant cost and schedule savings to the program. Modifications to the aircraft took place while the new portions of the tip tanks were manufactured by Material Science and Aerospace of Grove City, Ohio. The modifications that were made to the aircraft used as much of the existing fuel system as possible. The equipment built into the tip tanks for fuel quantity and transfer were taken and modified from the current C-130 external tanks. This design initiative limited the changes to the aircraft equipment and operating procedures, resulting in a fuel system that operates like the original. The equipment built into the tip tanks for fuel quantity and transfer were taken and modified from the current C-130 external tanks. This design philosophy was essential to maintaining the cost and schedule milestones laid out for the program. After completing the installation of the tip tanks, the tanks were tested for functionality on the ground. The aircraft also underwent a ground vibration test and wing flutter analysis to provide essential parametric data needed to determine the flutter-safe speed, which turned out to be well over the operating parameters of the demonstration flight plan. A short series of taxi tests were conducted to complete all necessary ground testing prior to the first flight. On March 2, 2007, the STOL Aviation C-130E test aircraft lifted off from the Rickenbacker International Airport with the first set of functional wing tip tanks on a C-130 aircraft. The first flight served as an aircraft and instrumentation functional check. That opened the door for the remaining flights. The demonstration flights continued with flight profiles that included climb and cruise tests, stalls, handling, maneuvering performance, as well as simulated assault landings and takeoffs. The test aircraft continued to exhibit excellent handling qualities, just as it did during the previous STOL Herk program. Takeoff and climb performance was strong. Stalls were clean with good approach warning and typical recovery with no major roll-off. And cruise efficiency showed increases. Most notable was the reduced stall speeds. All stalls performed in the program showed a nominal reduction of 12 knots with the tip tanks installed. As the flights progressed, the data collected was used to begin making improvements to the aircraft's takeoff performance. Reduced stall speeds allowed for reduced rotation and landing speeds. These reduced speeds subsequently resulted in significantly reduced takeoff distances. For example, a takeoff was performed at 143,000 pounds in 2,200 feet. An equivalent C-130E currently serving the Air Force fleet would require 3,600 feet in similar conditions. In order to fully quantify the aircraft's takeoff capabilities with the NP2000 propellers and tip tanks, a series of minimum control speed tests were performed. These tests included air and ground tests. The results of these tests showed that the aircraft remained controllable below stall speed with the larger rudder and dorsal installed. In conclusion, the SNO Aviation STOL Herk Functional Tip Tank Demonstration Program has shown that a C-130, modified with NP2000 propellers, and SNO Aviation designed extended dorsal fin, enlarged rudder, and wingtip tanks, has successfully demonstrated operation and functionality of the wingtip-mounted fuel tanks. Significant STOL performance enhancements, including a decreased takeoff roll of 1,100 to 1,600 feet for aircraft gross weights between 130,000 pounds and 155,000 pounds, and landing roll projections to yield reductions between 12 and 15% when using both reverse thrust and braking. Both the takeoff and landing improvements provide critical field length reductions of greater than 30% for aircraft weights up to 155,000 pounds. Other performance improvements included an increase in long-range cruise speed and specific range relating to fuel usage. However, these areas are being studied further in the STOL Herk Continuation Flight Demonstration Program, already underway and due to be completed in September of 2007. In this follow-on demonstration program, SNO Aviation will incorporate calibrated, instrumentation-grade fuel flow transducers, expected to increase the specific range data reliability by producing a calibration curve for each of the legacy fuel flow transducers, as well as additional specific range data points. The results of this follow-on demonstration program will provide a more concrete characterization or validation of the specific range improvements and tip tank contributions to the C-130 STOL Herk configuration. This concludes the video report of the SNO Aviation International STOL Herk Tip Tank Demonstration Program. Further technical data is available in the written final report available from the U.S. Air Force Research Laboratory at Wright-Patterson Air Force Base.